I'm going to talk about some of the web-based mapping tools that exist to both work with data and actually build interactive maps online. And I'm going to focus around a project that I worked on with the Pioneer Valley Planning Commission. So they have a lot of data about the communities that they serve, and those are 3 counties in Massachusetts. And so they have this data set, and they wanted us to go ahead and build them a dashboard so they could understand the different attributes that they had for the data in space. So the data that they sent us, was in shapefile format, right? So they sent us municipal boundaries, the planning authority boundaries, and the county boundaries that they work with. They have shapefile data. Shapefiles work with tools like ArcMap and kind of traditional GIS tools. And here we want to convert that to something we can work with more readily. So shapefiles are a binary format, come in a number of files that are associated with it, projection, etc. And there are some tools that are really helpful for working with this type of data. So one of these is MapShaper, which allows us to convert between different formats. So if we want to work with the shapefile that we were given, right, we can go ahead and just drag it right up to MapShaper, and this is what we got. So pretty easily just plots the shapefile. And so this gives us, tells us a little bit more about it, 69 polygon features, and the number of tools that are available here. We can actually simplify the shapes, and one of the most powerful things here is the tool that they expose kind of in the console here. So there are a number of different commands that you can run to manipulate the data itself. So we can see, we could go in and filter out states and then download our file with that simplified geometry if we want. So here we could maybe remove one of these towns from the data set. And they also allow you to export it. So the files that we're going to be able to work with are Geojson and TopoJSON, which contain the map data itself. And those are basically what we're going to want to work with. The difference between TopoJSON and Geojson is that TopoJSON allows geometries to share boundaries. So it's a little more compact format depending upon the type of geometry you have. Here it'll be a lot more compact, like this line between these 2 towns to be shared. And so we can go ahead and export our data now as a Geojson and work with that. One of the problems with this is the geometry projection doesn't get changed. So you can see when I hover here that the coordinate space I'm working in looks like it's in the 100,000s. So that's the shapefile's coordinate space, and we only uploaded the one shapefile, so it doesn't actually project back to lat long. So another tool that's really powerful is OGR to OGR. I prefer to use the command line version, but there is this online tool which allows you to convert to and from Geojson, and you can use shape to and from shapefile in Geojson. So here we could go ahead and upload our shapefile and convert it. So I actually ended up using OGR to OGR to do this conversion, and it will actually map the projections back to standard latitude longitude. Once we have our data in Geojson format, another tool that's worth checking out is Geojson Io, which is a pretty simple tool that allows you to explore the geometry in more detail. So this is our JSON data. We can go ahead and open our file, which we've converted to Geojson already, and we load it up, and these are the geometries we're looking at. This allows us to explore the data itself in a little more detail. So we can see here that the Geojson format itself is structured as such. So there's feature collection, and so that there's features. So the 2 main outer things, and features is a list, and each thing in the list is a feature, and that features have associated geometries. So this first feature is the town of Monroe. You can see it has a population, I assume in thousands, at various census dates, and it's got its 4 coloring problem solution. And it also contains, the important stuff for us is the map data. So it contains latitude, longitude coordinates of the bounding box for the polygon. Supports polygon, multi-polygon, and point types inside of Geojson. And the coordinate list is a list of the actual rings. So here, because it's a polygon, it goes straight in 3 deep to the coordinates. If it was a multi-polygon, right, this outer loop would actually contain multiple, but here this outer loop is just contain one ring. So we have the GeoJSON data, and we want to build a map that we can work with. The tool that we're going to work with is called Leaflet. So Leaflet is an open source JavaScript library, of course, for mobile-friendly interactive maps. And it's really powerful in what you can do pretty simply. So Leaflet, what it is a tiling backend. So we've seen what we can do with D3 with maps, but we didn't get this kind of stuff, like a Google Map looking thing. And the reason is because it's a lot more complicated to do. There's a particular problem which they solve, which is loading these raster tiles on the back end. So these are all actually image files that are loaded on the back end. And you can see as I zoom where these missing square tiles are and how they're filled in. So what this library accomplishes is it actually breaks up the file at different resolutions. So you can imagine having an image at this resolution for the whole globe, and it loads just the tiles you need at just the resolution you need them, which kind of allows this type of map to be possible. Google Maps does a similar thing, but Leaflet itself makes it really easy to do this kind of map. So to make the map you see above, really simple code. And you can point at really any tile backend. This is looking at the OpenStreetMap backend. Another popular source of vector tiles is Mapbox, who I think now employs the lead developer from Leaflet. Yeah, you can do a lot of things really, really pretty simply. So you might think, okay, we've got maps. We want to show some of our geodata on that. One way to do that is to integrate D3 and Leaflet. So this is an example from Mike Bostock himself, and this allows us to plot D3 shapes right on top of a Leaflet map. And here we get a hover on these, right? So we're actually interacting with these D3 shapes that are plotted on SVG. And you can go through the example of how to do this. I actually went ahead and did that. So to build out our mapping tool, we took these layers, or these individual town objects, and plotted them on the Leaflet backend. So this is using Leaflet, and the shapes are plotted with D3. You can see that they hide when you zoom. That's just set by a CSS attribute. They don't interact right now, and actually one of the things I want to point out is that this technique is actually a little flawed because there's no way to actually interact with them now, because the layer of SVG that you've plotted is actually buried now behind Leaflet. So if you try to add any interactivity to the map tiles themselves, you can't really do it using D3 because they've been embedded in these layers in Leaflet. So let me show you what that code looks like. So to actually do this, pretty simply, here's our map, right? Here's our map in Leaflet, pretty simple. And then if we want to go ahead and add D3 to that, right, we just get an SVG, which we actually put inside of the map itself. So this is going to put it inside the map element in the overlay pane. And then you can see it actually adds this CSS zoom hide class, right? If we got rid of that, then the map will stay the same when we hover. So we can look at that, right? If we don't have that, the map won't resize until we hover. Right, and the main thing that we're going to do is load up the GeoJSON file we have and go ahead and plot it onto the map. This loads some of the town data. And the main code is really just this here. It's pretty simple, like we've done maps in D3 before. So kind of the key thing that's different here is projecting points onto the Leaflet map. Again, we defined a geotransform, and we use D3's geopath to actually generate the path strings for the SVG. And this is the magic right here. So we're going to go ahead and select paths on this layer, add our collection.features, which is the GeoJSON data itself, add a path to each of these, and then set its attribute with the path function. So this is going to take in the data from each of these features and go ahead and plot it. Right? If we tried to add a mouse over, as an example, this will not work. You can see we weren't getting this mouse over, and that's because this layer is actually hidden. And this is the code to actually do the reset. So it'll actually resume on reset, and by grabbing the bounding box and doing a new plot. Right? Spend a little bit of time on this, but you could go ahead and use basically the same code without Leaflet and still get the interaction. So this is the basic D3 map, but using Leaflet as a backend doesn't get you that interaction. So how are we going to get a map that behaves a little more with interaction? So the way to do that is to use Leaflet itself. So this is closer to the final version of the tool that we built for them. And you can see that we do get interaction on these tiles. And the way that this interaction is accomplished is by using Leaflet's JSON API itself to plot these areas using Leaflet. And the interaction itself is implemented then by Leaflet. So you might think, oh, this version that Mike had here had an interaction, but this is actually just a CSS hover attribute. So to get this kind of interaction, let's take a look at what that looks like. So this code is a little more in depth to do this. This is version 2. You see we define a lot of different stuff. So here we're drawing the map in Leaflet the same way we did before, right? And this is our, we're actually using a map box backend for the tiles. Here we're using their gray tiles. So the map imagery is provided by Mapbox. You can actually see this little code here shows that box. And then we go ahead and add the controls on the map using Leaflet's API. So L is the Leaflet library, and we can add different controls. So info is going to be a Leaflet control, and it has a number of functions which you can set yourself. So the onAdd, when you add it to the map, this is what gets happen. It creates a div, calls update on itself, and the update of itself sets the variable type in the header and the town you hovered over. So what you're seeing is this info box here. So we build that out as a control. Similarly, we build out the legend as a control, and we set its onAdd to create itself, except we don't update it because we need to wait for the data to be loaded to actually draw the legend boundaries. So here is the code. We'll actually go ahead and generate that legend. You see it's a little more in depth. It goes ahead and creates the labels manually. We're still using D3, and we're using D3's scale module to go ahead and get the color scale. So here, get color is a D3 scale. So if we want to look at what that is, so we can see D3 get color is just a D3 quantized scale, right? And of course, it'll have to map to the real value. So we reset its domain when the legend gets added to the map, and set the colors manually. So this is how the legend is built, and then really what we're interested in is the interaction. So how do we get these callbacks? I already gave away the answer there. The answer is to use the callbacks on each of those map tiles. So the way that we do that is on each of those, we'll go ahead and define a function highlight feature, right? And what this is going to do is this is going to get called when you hover. So what it's going to do, it's going to change the style on the layer, and then bring it to the front. And then when you hover off, this is what the function we're going to call. So reset highlight, right? We're just going to return those styles to what they were before, and go ahead and update the info box. So we're updating the info box with the data statistic as we hover. Let's move on a little bit. This is going to be the draw sidebars, what we're going to use for the on-click callback. We're just going to take a function of the town you've clicked on, and let's see where those are implemented. So on each feature, right, is where we go ahead and encode each of these functions. So we have our mouse over, mouse out, and click functions set on the layer itself. So on each feature, right, takes in the feature and the layer. And for that layer, we set the mouse over, mouse out, and click attributes to functions, which will get called on each of those. So this is all implemented through D3. And we can go ahead and see that the on each feature, right, is set here. So once the data itself is loaded, the Geojson data itself is loaded, we add that to Leaflet just using Leaflet's Geojson API. So here, this is again, L is a Leaflet library. We just call the Geojson, pass it in our map data, which is collection. It's just the Geojson string, and actually it's an object at this point. D3's JSON has converted it from a string to an object when it made the request, and then we actually go past that on each feature object to each of these, which defines the callbacks. And then quite simply, we add it to the map. So here, the variable map itself was the leaflet map, and that's really it. The rest of the code here, we're going in and adding some charts on the side and to the bottom using D3. So this is the actual callback, and we can kind of see how this works. So we get the styles to be set and unset on hover, and on click, we'll go ahead and call the code which went ahead and grabbed the sidebar and plotted the new statistics. So we have a fully interactive map, and you can see that the actual resizing is handled pretty nicely by Leaflet. So it resizes as the map is resized. So it does a really good job with that. So that's how to implement the full interactive map using Leaflet.